let's talk about triangles. A young child might think all 6 of these figures are triangles because all of them resemble triangles. Some of them actually are triangles. Let's look at what attributes make a shape a triangle. A is not a triangle because it has this opening. We need to have closed figures to be a triangle. B is not a triangle because it has curved sides. We need to have line segments for the sides. C also has curved sides. We need line segments. D has 1, 2, 3, 4 sides. A triangle only has 3 sides. So closed figure made of line segments with 3 sides would be our triangle. E and F are both triangles, although young children sometimes think triangles have to have the base parallel to the bottom of the paper because most of the examples they've seen look like that. They also have mostly seen acute triangles with 3 angles less than 90 degrees, so this throws them off. Stepping back, a triangle is a special kind of polygon. Polygons are simple closed curves in a plane. I have an extra word there, in a plane. So a curve that's not simple would look like this, where you have to cross over a line you've already drawn. That doesn't happen in a simple curve. The closed curve we already talked about. So here we are going to talk about triangles with 3 sides and 3 angles. So to start with, we might have recognized shapes that resemble triangles, and then we learn the attributes that make a shape a triangle. Then we can get a little more sophisticated. All 3 of these are triangles, and we should be able to recognize them as such, but we can have special kinds of triangles. In this case, we'll be classifying triangles by their side length. An equilateral triangle has 3 congruent sides. Congruent for our K through 8 purposes means the same size and shape. If I were to take one of these line segments and pick it up and move it, I could place it on top of a second line segment and they would perfectly line up and overlap. So line segment BC, I could perfectly line up and overlap with line segment AC. We have 3 congruent sides. Next, we have the isosceles triangle that has 2 congruent sides. The third side is a different length. And finally, our scalene, which has 3 sides with different lengths. So we have no congruent sides. One way to remember this, look at the first letter of each name. Equilateral has 3 horizontal lines, 3 congruent sides. Isosceles has 2 horizontal lines, 2 congruent sides. Scalene, no horizontal lines, no congruent sides. We can also classify triangles by angles. Acute triangles have all of the angles less than 90 degrees. Right triangles have one angle that's exactly 90 degrees that we mark with a little square right there. Obtuse triangles have one angle that's greater than 90 degrees. So all of these are triangles, but as we get more sophisticated, we can talk about types of triangles, and then we can start to compare triangles to other triangles and see how these attributes can play together. We might ask the question, can an isosceles triangle ever be an obtuse triangle? So we're going to take a little field trip over to Math is Fun and play with an interactive triangle. So here we are with an acute triangle. I'm going to change to an isosceles triangle. That's what we were looking at. We can see 2 congruent sides, each 176 units long, and I can take the vertex here, C, and I can move this down, and right now I have an acute isosceles, all less than 90 degrees. And here, if I can stop at the right spot, I can also have a 90-degree triangle, so a right isosceles triangle, and I can keep going such that I have an obtuse angle. So there's my obtuse isosceles triangle. Indeed, I can have one. I could have started with the obtuse triangle. Let's find another one here, an obtuse triangle. There's my 109 degrees. And I could take one of these sides here and see if I can make it. There is a isosceles, two sides 173 in length, and obviously I can have the scalene in here as well. I can't have an equilateral. If we look at an equilateral triangle, three equal angles, three equal sides there, and if I want to have longer sides, my angles still stay at 60 degrees, so I could never have an obtuse or right equilateral triangle. We can summarize this in a Venn diagram. So I could have one of my ovals here on the left represent isosceles triangles, and I could have the oval on the right represent obtuse triangles. Everything I draw will be a triangle, so it'll have the three sides closed made of line segments. The isosceles will have two congruent sides. The obtuse will have one angle greater than 90 degrees. In the center, because it's part of both ovals, the shapes I draw should have one angle greater than 90 degrees and two congruent sides. So over here on the left, we need to start with two congruent sides, but it can't have an angle greater than 90 because that belongs in the overlapping region. So I need to have no angles greater than 90 degrees. So let's start. We saw we could have one that was 90 degrees. So I'm going to try my best to draw two congruent sides, but then I'll mark them to show that that was my intent. And I'll mark that I intended this to be a 90-degree angle. Now I can draw an acute one as well, kind of our classic acute triangle. I'm going to say those two are the same length here. And in the center, I'm going to have an obtuse angle, so definitely bigger than the corner of a piece of paper. And I'm going to try to have these two sides be the same length. I'll mark them with my intention. And there is my obtuse isosceles triangle. Over here on the right, I need to have an angle bigger than 90 degrees, but now I need to carefully make sure that my three sides are three different lengths. So we can have an isosceles triangle that is right or acute. This side is isosceles, not obtuse. The overlapping region has obtuse and isosceles. And then on the right, we have obtuse, not isosceles. So it's got to be scalene because we know we can't have equilateral.